In this video, we'll solve a system of equations using Cramer's rule. So we have three equations and we have three variables, x, y, z. Now looking at the system of equations that we have right now, x, y, and z are all over the place. So first thing that I'm going to do is rearrange them so that on the right side we have only the constants, and on the left side we are going to have x, y, and z in this particular order for every single equation. So we have x plus y plus z equals 3. The second line is 2x minus y plus 3z equals 4. And the third one is negative 3x plus 4y minus 2z equals negative 1. Now I'm also going to put 1 in front of the variables that don't have any number, because that's the actual value that we have, just to emphasize that the coefficients of x are 1, 2, negative 3. The coefficients of y are 1, negative 1, 4. The coefficients of z are 1, 3, negative 2. And the constants are 3, 4, and negative 1. So now, using Cramer's rule, we are going to calculate our first determinant. So the delta is the determinant made by the columns of the coefficients of the variables that we need to find, of x, y, and z. So 1, 2, negative 3, the yellow one is the coefficients of x, 1, negative 1, and 4, coefficients of y, 1, 3, negative 2, coefficients of z. This is a 3 by 3 determinant, which we can calculate in many methods, but I'm going to use the one where we copy the first two rows, and then we multiply the terms on the first diagonal and then parallel to that. So we get 2 plus 8 minus 9 minus, and now we do the same with the secondary diagonal. So 1 times negative 1 times negative 3, that's 3, plus 3 times 4 times 1, 12, plus negative 2 times 1 times 2, negative 4. And when we compute this, we end up with negative 10. So to find delta x, we go to delta, and instead of the first column, we put the column of coefficients, the purple one, 3, 4, negative 1. And we copy all the other columns from delta the same. So 1, negative 1, 4, and 1, 3, negative 2. Now in order to solve the determinant, we follow the same rule. We copy the first two rows and then the main diagonal. So we have 3 times negative 1 times negative 2, that's 6, plus 4 times 4 times 1, 16, plus negative 1 times 1 times 3, negative 3, minus, and now we write the second diagonal, and we have 1 plus 36 minus 8, and when we do the computation, we end up with negative 10. Delta y, well, in delta, instead of the middle column, we put the column of the coefficients, and the other ones we copy them. So 1, 2, negative 3, 3, 4, negative 1, and 1, 3, negative 2. So the column of the coefficients, now it's on the second place. And we computed by copying the first two rows, and we get 1 times 4 times negative 2, negative 8, plus 2 times negative 1 times 1, negative 2, plus negative 27, minus, and now the secondary diagonal, 1 times 4 times negative 3, negative 12, minus 3, minus 12, and when we do the computation, we end up with negative 10. Delta z means a 3 by 3 determinant where column of z it's 3, 4, negative 1, and the other two columns we copy them the same. 1, 2, negative 3, 1, negative 1, 4. And again, in order to compute this, we are going to copy the first two rows, and we're going to multiply them. So we get 1 plus 24 minus 12 minus, and the secondary, 9 plus 16 plus 2, and that is also negative 10. So having all these computed, we can say x is delta x over delta, so it's negative 10 over negative 10, which is 1. Y is delta y over delta, so it's negative 10 over negative 10, which is 1. And z is delta z over delta, which is negative 10 over negative 10, which is 1. So the solution is the triple xyz, which is 1, 1, 1 in our case, and you can check that by mentally replacing the values. 1 plus 1 plus 1 is 3, 2 minus 1 plus 3 minus 4 is 0, negative 3 minus 2 plus 4 is negative 1, so it checks out.